All right, yesterday we looked at geometric series and sequences, but the series we looked at were finite, meaning that they terminated. They only had a set number of terms. However, you can also find, unlike arithmetic series, where you can't find an infinite sequence because you can't find the infinite series because the sum will be infinity, you can find the sum of an infinite geometric series, okay, sometimes. So the formula for an infinite geometric series, so S infinity, okay, so infinite goes on forever, is equal to the first term divided by 1 minus r. Okay, as long as r is less than 1. As long as the ratio is less than 1. Okay. Or if that ratio is less than or equal, well, no, it'd have to be less than 1. If the ratio is larger than 1, there is no sum, okay? It would be infinite. You'd have an infinite series. Okay, but as long as the ratio is smaller than 1, you can have a series. Okay, so find the sum if it exists. These are infinite. They go on forever. They don't have a last term because they just keep going. So we need two things. We need the first term, which in this case is 21, and we need the ratio. If you don't know the ratio, which is kind of hard to see from 21 to 14, you just need to take the second term and divide it by the first term. So 14 over 21. 7 goes into 14 2 times, 7 goes into 21 3 times. So the ratio is 2/3, okay? You're multiplying each time by 2 over 3. Okay, 21 times 2/3 is 14. 14 times 2/3 is 28 over 3. Okay, so this is smaller than 1. So we have a infinite series. Okay, so it definitely exists. So the sum of this infinite series is equal to the first term, a1, so 21, over 1 minus 2/3. Okay, 1 minus 2/3, that's 1/3. So 21 divided by 1/3. So 21 divided by 1/3. Changing that to multiplication, so 21 times 3, multiplying by the reciprocal. 21 times 3, that's 63. Okay, so the sum of this series, which is infinite, is 63. Kind of interesting. It goes on forever, but if you add all of those infinite terms together, you get 63. All right, number 2. First term, of course, is 32. The ratio, it's kind of hard to see, but we're going to take the second term and divide it by the first term, so 40 over 32, and simplify that. Well, 8 goes into both of these. 8 goes into 40 5 times, and 8 goes into 32 4 times. So our ratio is 5 over 4. Well, that's actually a problem because that's greater than 1. That's 1.25. All right, so this sum is going to go to infinity. You can tell because the numbers are getting bigger. 32 plus 40 plus 50. So the numbers are getting bigger. All right, so this does not exist, okay? The sum does not exist. It goes to infinity, does not exist. All right, number 3, we have 1/12 minus 1/6 plus 1/3 minus, okay, so the first term is 1 over 12. The ratio, well, I don't know, but we're going to have to take the second term and divide it by the first term. So the second term is 1 over 6, and we're dividing that by the first term, which is 1 over 12. Okay, so that's negative 1 over 6 divided by 1 over 12, which if we write this as multiplication, negative 1 over 6 times 12 over 1, okay, which is negative 12 over 6. This is negative 2. Okay, so the ratio here is negative 2, which is not bigger than 1. Okay, so we can use it, okay, because that's not larger than 1. So this infinite series is equal to the first term, 1 over 12, divided by 1 minus r, so 1 minus negative 2. That's 1 over 12 divided by 3, or 1 plus 2, which is 3. Okay, so we write that as division. That's 1 over 12 divided by 3. So rewriting that as multiplication, 1 over 12 times 1/3. As 1 over 36. So our series, our infinite series here, 1/12 minus 1/6 plus 1/3 is 1 over 36. This is what it all adds up to if you keep going to infinity, 1 over 36. Sometimes you may see this series in summation notation. Okay, I mean, that's possible. We know that's possible. If it's an infinite series, it will always start at the first term, and it will always say that the last term is infinite, so it'll have infinity at the top. It's very easy to determine the first term and the ratio when it's in this form. The first term will always be this, and the ratio will always be this. Okay, it's very easy because this is the first term, because plugging in 1 turns this entire thing, 1 minus 1 is 0, so this whole thing becomes 1, so that's the first term. And the ratio here, how much is getting multiplied each time, is just this, okay, 5/6. So it's being multiplied by 5/6 to get to the next term. Okay, so this is always A1, this is R. Okay, so if I want my infinite series here, R is smaller than 1, so this is fine. So it's the first term, which is 8 over 3, divided by 1 minus the ratio, which is 5 over 6. Okay, so that's 8 over 3 divided by 1 minus 5 over 6, so common denominator, that would be 6 over 6 minus 5 over 6, which is 1 over 6. Okay, so we're looking at 8 over 3 divided by 1 over 6. Changing that to multiplication, that's 8 over 3 times 6 over 1. So that's 48 over 3, which is 16. So this first series sums to 16. Okay, so this is equal to 16. The sum of that infinite series is 16. Number 5, once again, this is the first term. This is the ratio. So our infinite series would be the first term, 1 over 8, divided by 1 minus 1 over 12, our ratio. That's 1 over 8 over 11 over 12. That's 1 over 8 divided by 11 over 12. Changing that to multiplication, 1 over 8 times 12 over 11, which is 12 over 88. So they would both have 4 in common, I think. Yeah. They both have 4 as a factor. So 12 divided by 4 is 3. 88 divided by 4 is 22. So that sums, number 5, that series sums up to 3 over 22. Infinite series sums up to 3 over 22. And we look at number 6. This is the first term. This is the ratio. Well, 8 over 5, that is larger than 1. Okay, that's like 1.8 or 6. It's 1.6. Okay, so that sum does not exist. Okay, it goes to infinity. All right, that sum doesn't exist. It goes on to infinity. All right, write each repeating decimal as a fraction. Okay, so we can do this by thinking about the repeating decimal in a different way. Okay, so if we look at 0.8 repeating, okay, that's 0.88888888, etc. And that can actually be expressed as an infinite series of sums, okay? 0.8 plus 0.08 plus 0.008, okay, adding, and then etc. Adding all of those together gives you an 8 in the next space. Okay, so we can use the infinite series formula to rewrite this as a fraction because we have two things here. We have our first term, which is 8 over 10, 0.8, that's 8 over 10. So our first term, 8 over 10. And we have our ratio, which is 1 over 10, okay? It's multiplying by 1 over 10 each time, because this is 8 over 100. But we could easily see what the ratio is by doing 0.08, the second term, divided by the first term, 0.8. And if you do that, 0.08 divided by 0.8 is 0.1, which is 1 over 10. Okay, so the ratio here is 1 over 10. All right, so the first term is 8 over 10. So this infinite series would be the first term, 8 over 10, divided by 1 minus the last term, 1 over 10. Okay, so that's 8 over 10 divided by 10 over 10 minus 1 over 10, so that's 9 over 10. So that's 8 over 10 divided by 9 over 10. Writing that as multiplication, that's 8 over 10 times 10 over 9. Of course, these 10s cancel, and we're left with 8 over 9. Well, go ahead and check that in your calculator and see if it gives you a repeating decimal. And it does. If you put 8 over 9, 8 divided by 9 in your calculator, you get 0.8 repeating. Okay, so this is how this decimal can be expressed as a fraction, 8.9, or 8 over 9. And we got to this by using the by thinking about it as an infinite series.